Students of third prep science for second term, as we have today to start with the first lesson, as we have to know what is meant by potential difference, electric current intensity, and the electric resistance. At the same time, today we will study the electric cells. Electric cells, as we have here, to know how can we recognize the connection of the electric cells to form a battery. But firstly, we should know how can we differentiate between the two types of the electric current, as we have here alternating current and the direct current. We have two types of the electric current, as alternating current أو متغير, and direct current, which means اللي هو constant electric current intensity and constant direction at the same time. يعني ثابت ومتغير. So let's go to start with the first point in this lesson today, as we have lesson 2, unit 2, the electric current and the electric cells. As we have here to know the unit 2, lesson 2, electric current. النهارده بناخد مع بعض electric current. As we have here, talk about the electric current and the what and the electric cells. Electric cells connected together to form what? To form battery. As we have here to know, as you see, here we have electric circuit, دايرة كهربائية زي ما بنسميها بالعربي. And this electric circuit we have here battery. This battery will produce what? Will produce electric current. This electric current will pass through the electric wire أو السلك inside the what? Inside the electric circuit. So we have to know first point in this lesson, as we have sources of the electricity أو مصادر الكهرباء, sources of the electricity. Number one, we have electrochemical cells. What? We have electrochemical cells, as we studied before in first prep. خدنا في أولى إعدادي electrochemical cells or electro أو electric change the chemical energy into electric energy. So here, how can we mention the electrochemical cells? Number one, converting the chemical energy to electric what? To electric energy. To electric energy. يبقى change here, we talk about the what? Change the chemical energy into electric energy. Into what? Electric energy, as we have the first point in what? In electrochemical cells. Number two, as what here? Produced the direct current. Produced what? Produced the direct current. خلي بالنا من البوينت دي كويس قوي. Produce the direct current. We talk about direct D and we talk about current C. As we have here simple cell, as we studied before, this simple cell has chemical reactions inside it to form electric current, as we have here, converting the chemical energy to electric energy. تمام? And produced what? Direct current. Okay, number one, electrochemical cells. Number two, we have dynamo or dynamos as electric generators. So here we talk about dynamo or electric generator, مولد كهربي. So what is meant, or the dynamos produced what? Firstly, we should know dynamos change what? Convert or change the mechanical or kinetic energy to electric energy. To what? To electric energy. As we have here, change or converting mechanical, we can say kinetic or mechanical energy to electric energy. To what? Electric energy. Okay. So we should differentiate between electrochemical cells, change what? Change chemical energy into electric energy. But here we talk about what? We talk about dynamo, and any dynamo converting the mechanical energy or the kinetic energy into electric energy. And dynamos produced what? Current Here we have to know they produced what? Alternating current. They produce what? They produce alternating current. So we talk about alternating A current, C. Alternating what? Current. A, C. We should differentiate between alternating current, and in the previous slide we have direct current. So how can we differentiate between direct current and alternating current? We have direct current. Direct current, and its symbol is DC. Direct current, which means what? Number one here, constant intensity and direction. So it has constant electric current intensity, يعني electric current intensity ثابتة ما بتتغيرش, and direction at the same time. Its direction is constant, which means ثابت, doesn't change. How come? Because if it moves from point A to point B, has constant direction, not from point B to point A. Has only one direction. Number two, here we have transferred to short distance. بتتنقل لمسافات صغيرة. Transferred to short distances. Number three, it can't be converted to alternating current. Here we have three main points. As we have here, dear students, we have number one, as you see, constant intensity and direction. Number two, transferred to short distance, not long distance. تتنقل لمسافات صغيرة. And number three, can't be converted to alternating current. ما ينفعش, we can't change direct current to alternating current. So we have to know the uses of the direct current. As we have two main uses here of direct current. The first use is what? Electroplating. يعني ايه electroplating؟ يعني paint by electricity. الدهان بالكهرباء. Okay, and we will watch now video, but after we know the second use. هنعرف second use. The second use of direct current here is what? Some are يعني we use direct current to operate these machines, like remote control, for example, mobile, earpiece, for example. It depends on what? Depends on direct current, and direct current is produced, for example, from what? From the electrochemical cells, as we talk about the dry cell. So here, dear students, we should know how can we differentiate firstly between electrochemical cells, and number two, between the dynamo. Electrochemical cells change chemical energy into electric energy. Electrochemical cells produce direct current. So what is meant by direct current? Direct current, which means what? Number one, has constant intensity I and direction, which means move in one direction. Number two, transfer for a short distance, يعني ممكن ننقله لمسافات صغيرة. Number three, can't be changed into what? Into alternating current. Okay. At the same time, we have alternating current is produced from what? From dynamo. Dynamo change what? Mechanical energy into electric energy. Some students can say kinetic, يعني حركة, to produce electric current. At the same time, the dynamo change mechanical energy into electric energy and produced alternating current. Okay? From the uses of direct current, من استخدامات الdirect current, we know we have the electroplating. electroplating يعني بدهن حاجة by electricity. As we have to, for example, to paint middle medallion with gold, spoon with silver. عايز ادهن معلقة بالفضة، مية الفضة يعني زي ما بيقولوا. How can we paint? We use direct current here in this case by this machine, as you see here in this video. As we bring here a piece of copper, for example, okay, and we put a coin on the other side, قطعة من المعدن يعني أو العملة. Okay, copper here, maybe copper, maybe gold, maybe silver, براحتي. And on the other side we put what? We put the coin here. Coin has what? Has a silver color. Okay, after a while, بعد فترة, we can see here coin is painted, الدهن, with what? With copper. So we use what? We use here direct current to use in electroplating, as you see in front of you. Okay. Again, dear students, now we know the uses, عرفنا استخدامات of direct current, as we have here, here please, as we have here, زي ما احنا شفنا in this video, direct current, use of direct current in electroplating, and direct current moves in constant direction and constant intensity. Okay. So we have another type of current or electric current. We have alternating current. Alternating current. تعالوا نشوفه مع بعض. قبل ما نشوفه طبعا we have direct current has constant, again, constant intensity and direction. We have here, as you see, we have graph. عندنا graph زي ما احنا شايفينه قدامنا. This graph has two axes. Axis I, which means electric current intensity, and axis here is T. So we have two, as you see here, we have I and T. At the same time, we have what? We have a straight line parallel to time axis, as you see here. So we talk about what? We talk about what here? We talk about the direct current. We talk about what again? We talk about direct current or direct electric current. Maybe in the second term exam we have question, illustrate by drawing, by graph, the direct current. يبقى we should remember how can we draw a relation between electric current intensity and time. Between them we have direct current, and the direct current has what? Constant intensity and direction. So we have a straight line parallel to what? To time axis. We have another current here as we talk about alternating current, AC. We have AC, alternating current, AC. Alternating يعني متغير, يعني changeable. So we have to know, number one, variable intensity and direction. Variable intensity and what? And direction. يعني we can change its intensity and we can change its direction. ممكن اغير اتجاهه, ممكن اغير قوته او شدته, electric current intensity. Number two, can be transferred to a long distances. ممكن انقلهم مسافات كبيرة between governorates, ما بين المحافظات, between states, between countries. Okay. Number three, here we have it can be converted to direct current. So we have alternating current, variable intensity and direction. Number two, can be transferred to a long distances. ممكن ننقلهم مسافات كبيرة. Number three, can be converted to direct current. Can be changed into direct current. ممكن احوله واخليه direct current. So it's used in what? As you like. As you like. ممكن اكتب اللي انا عايزه هنا. In alternating current. We can say use in lighting houses, use in lighting streets, use in electric appliances as television, as washing machine, as you like. So how can we know the uses of direct current? Only we have two uses. Number one, as here we have, yes, electroplating, and some electric machines, for example, like remote control. For example, we use electric cells أو اللي هي الباتري, and battery produced direct electric current. Here we have the relation between I and T, as we have here straight line parallel to the time axis. But here in this case we have variable intensity and direction. صح أقول له. So we have two axes here, I and T. But as you see here, we have what? We have variable intensity and direction. Variable what? Intensity and direction. شوفوا كده. Variable متغير in intensity and direction. We can change its direction, we can change its intensity, and here we talk about what? We talk about the alternating current, which means changeable in intensity and direction, can be transferred for a long distance, and can be converted to what? To direct current. So if we have here, dear students, to know how can we prefer to use what? We prefer to use alternating current or direct current. You prefer to use alternating current or direct current. My teacher, as I was in prep stage as you now, asked me if we have 100 options or 99 options, عندنا 99 ميزة in direct current, and we have only one option, عندناش غير ميزة واحدة in alternating current, we will use what? We will use alternating current. Why? Because alternating current can be changed into direct current, can be transferred for long distances. So here we have many options. If we have only one option in alternating current and it can be changed into direct current, so we have only option here and 99 options here, so we have 100 options. 100 طبعا هنا ده رقم for example يعني. But if we have direct current only, direct current can't be changed into alternating current. So if we have 99 options here and we have only one option here, we can't get this option, مش هعرف احصل عليها. So we have give reason for. We prefer to use direct alternating current than direct current. Only because it has variable intensity and direction, can be transferred for long distances, and number 3, can be changed into direct current. Can be changed into direct current, as we have here this give reason for. يلا نشوفه مع بعض. Okay. Here we have give reason for the alternating current. The what? The alternating current is preferred, مفضل, than direct current. So we try or we like to use what? Alternating current than direct current. Why? Because we have 3 reasons. Number 1, because it can be changed into direct current. يبقى طبعا حاجة ممتازة. It can be transferred or transmitted for long distances. ممكن ننقله مسافات كبيرة. Number 3, has variable intensity and direction. Has what? Variable intensity and direction. So we have many or at least 3 reasons. Can be changed into direct current. Number 2, can be transmitted for a long distances. Number 3, has variable intensity and direction. Okay. So here dear students, we have to know how can we have electric cells. Electric cells, as we have three, for example, in radio or in cassette, we have, for example, three electric cells form a battery. Electric cells change chemical energy, electrochemical cells change chemical energy into electric energy. Sometimes we can see the electric cells connected one after another, واحدة ورا واحدة. And sometimes we connect the electric cells beside each other like that. يبقى we have sometimes connect electric cells one after another, ورا بعض, as series connection. And sometimes we have electric cells connected beside each other, and we have here to talk about parallel connection. So how can we use this connection, and we use this connection for what? احنا بنحب نستخدم ال connection of electric cells here like that, or for what? And we have another connection for what? Let's go to show how can we connect electric cells to form a battery by some conditions. As we have here, dear students, we have connection of electric cells. Connection of what? Electric cells. We have number one, connection in series. Connection in series, as you see here, electric cells are connected in series. Each positive pole is connected with next negative pole, and so on. Each positive pole is connected with next negative pole, and so on. So what is meant by connection in series? هقول له اهو connected or connecting the negative pole of the first cell to the positive pole of the next cell, and so on. وهكذا. Maybe I start with negative pole, and maybe I can start with positive pole, as you like. But each positive is connected with next negative, or each negative is connected with the next positive pole of the next cell. Each one from these devices here is called cell. كلها اسمها electric cell. طبعا, as we know, electric cell change the chemical energy into electric energy. Okay, so how can we calculate, ازاي نقدر نحسب the electromotive force? We know the electromotive force, EMF. Okay, electromotive force of these cells together. And we know electromotive force is what? From the previous lesson, من الدرس اللي فات قلنا electromotive force, it is the potential difference between what? Who can remember? Between the two poles of the electric cell when the electric circuit is opened. So in the series connection, how can we calculate? As you see here, how can we calculate the electromotive force? We calculate the electromotive force of the battery. واحد يقول لي يعني ايه battery؟ اقول له all electric cells. Each cells connected in what? In series. How can we connect them? For example, we have here, هقول له E of battery, which means what? E, which means, yes, the electromotive force. E here, which means what? Electromotive force. Equal what? Equal E1 times number. N, which means what? N, which means number of cells. We have here example. These cells, we know the long line is positive and short line is negative. As we have here, positive, negative, and so on. As you see here, positive, negative, and so on. Each one has electromotive force equal what? Equal 1.5 volts. 1.5 volts. 1.5 volts, and so on. We have how many? We have 4 electric cells. So how can we calculate the what? How can we calculate the E تحت اهي of battery? In this case we can say what? هقول له yes, E1 times what? Times number. E1 times number. E1 times N. E1 equal how many? Equal 1.5 volts. Each one of them has 1.5 volts. And times number. Number equal how many? 1, 2, 3, 4. Times 4 equal how many? Yes, equal 6 volts. So in series connection, we calculate the electromotive force of the battery by what? طبعا in this case we can say yes, E of the battery equal number times what? E1, which means electromotive force of any cell here in this case. Okay, we have another way of connection here, as we have connection in what? In parallel, as you see here in front of you. We have what? All, as you see, all positive poles are connected together. As you see, all positive poles are connected together. And at the same time, all negative poles are connected together. Okay. So we can say that in the definition to describe the connection in parallel of the electric cells. هوصفه ازاي؟ اقول له connecting all positive poles together and all negative poles together. يبقى we connect all positive poles together and connect all negative poles together. So in this case, how can we calculate? ازاي نقدر نحسب the electromotive force of the battery? In this case, dear students, the electromotive force in cells connected in parallel equal what? Equal E1 only. We have no number here. Which means what? لو أنا عندي for example 30 cells 30 cell connected in parallel, electromotive force of these cells equal electromotive force of one of them. Yeah. يبقى أنا عملت كده ليه؟ يبقى in the other or in the previous we connect, as you see here, we connect the electric cells in series. Why? For what? هنا هقول له to obtain. إيه السبب؟ We connect them in series to obtain maximum electromotive force. As we know, E1 times number. In what? In series connection. But in parallel connection, electromotive force equal E1 only. So here we obtain what? To obtain minimum electromotive force. To obtain what? Yes, to obtain minimum electromotive force. As we have here, this example, we have 3 cells. Each one of them has 1.5 volts electromotive force. So the electromotive force of what? Of the battery equal how many? In this case, electromotive force of the battery equal, yes, equal E1 equal 1.5 volts. 1.5 volts. Okay. So dear students, now we can connect or we can differentiate between the series connection of the electric cells and the uses or the benefit to connect the electric cells in series connection. At the same time, we have to know how can we connect the electric cells in parallel connection. We connect electric cells in series connection to obtain maximum electromotive force. Why? Give reason. Only because electromotive force equal E1 times number according to the number of the electric cells. At the same time, if we connect the electric cells in parallel connection, we obtain minimum electromotive force. Okay, minimum electromotive force. Why? Because electromotive force of the cell is what? In this case, equal E1 only. Now, we have 100 cells, 100 واحدة, and they put and connect in parallel connection. Electromotive force equal E1. كأني حاطط واحدة بس. Why? Because we connect them in parallel connection. Okay? We have here a little video to show the connection of the electric cells as you see here. زي ما احنا شايفين هنا الفيديو ده. Series connection. Each positive pole is connected with the next negative pole. Each positive pole is connected with the next negative pole as you see in front of you. زي ما احنا شايفين كده. Okay? And why we connect them like that? Why? To obtain what? To obtain maximum electromotive force. Each positive pole is connected with the next negative pole, or each negative pole is connected with the next positive pole. Okay? Okay? طيب. We can see now they are connected in series connection. And why we connect them like that? We can see the monitor of the voltmeter here. 0. Yes, 0. But when we try to measure the electromotive force in this case, because they connect in what? In series connection. ونركز بقى كده معاه. اهو بصوا. The number will change here on the monitor of the electromotive force of the voltmeter. بصوا. Will increase 25.8 volts. So we connect them in what? In series to what? To obtain maximum electromotive force. I hope you understand now why we connect the electric cells in series connection. ازاي بنوصلهم ليه in series connection. At the same time we have another video here to obtain minimum electromotive force عشان نشوفها كده مع بعض. As we connect them in parallel connection. جيبها لكم دلوقتي. We obtain now the parallel connection of the electric cells on the monitor, please. As we have here, all positive poles are connected together and all negative poles are connected together. كلهم متوصلين. All positive poles are connected together and all negative poles are connected together. As you see here, we obtain minimum electromotive force. We obtain what? Minimum. So here we can we talk about the parallel connection of the electric cells. So we connect them like that to obtain minimum electromotive force. So now, dear students, we can differentiate between parallel and the series connection of the electric cells and how can we deal with each one of them. Okay. طيب. So now, dear students, how can we answer questions in the exam? By drawing here. We should draw the problem. if you have problem, for example يعني like we have يعني ناخد problem كده نحلها مع بعض. You have 4 cells, each one has electromotive force equal 1.5 volts. 1.5 volts. Okay. How can you connect them to obtain number 1 EMF equal 6 volts. Number 2 EMF equal 1.5 volts. Number 3 EMF equal 4.5 volts. As we have number 1, we want to connect the 4 cells. Each one of them has 1.5 volts to what? To obtain electromotive force equal what? Equal 6 volts. ازاي بقى؟ اقول له we connect them series. Each positive pole is connected with the next negative pole. We have how many cells? We have what? We have 4 cells. Okay? Okay? We have 4 cells. لازم اكتبهم 4 cells. If we have 3 in the problem, we should deal with 3. Okay? Okay. So we connect them in what? In series connection, as you see. So we have to write negative, positive, positive, negative, positive, negative, positive, negative, and positive. In this case, we have 4 cells. Each one of them is connected in series. So we have E1, E2, E3, and E4. 4 times what? Times 1.5 equals 6 volts. So we calculate number 1. حلينا number 1. We have another problem. Number 2, how can we connect them to obtain electromotive force equal what? Equal 1.5 volts. In this case, we try to connect them. All are connected what? Parallel. All positive poles are connected together and all negative poles are connected together. Okay, like that. So we have positive, 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 and positive. Negative, 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 and negative. So all positive poles are connected together, as you see, and all negative poles are connected together, as you see. So we have here what? We have parallel connection in this case to obtain minimum electromotive force. To obtain what? To obtain, yes, minimum electromotive force. So we have 1.5 volt, and in this case electromotive force equal E1, and E1 equal how many? 1.5 volts. اللي هي فين؟ اهي 1.5 volts. We have number 3. How can we connect them to obtain 4.5 volts? We answer in another page. E M F equal 4.5 volts. We have here a mixing connection. لازم اوصل توصيلتين مع بعض. Not parallel only, not series only, because we talk about 4.5 volts. Okay. So here we have, if we have, as you see, two series equal how many? Two series equal how many? Equal 3 volts. E times number. E equal 1.5 times 2 equal how many? Equal 3 volts. Type. And we have two parallel. As you see, two parallel. Two parallel equal how many? Yes, equal 1.5. Because E1 equal, our electromotive force equal what? Equal E1. So we have a mixed connection here between the electric cells. As we have here, number 1, positive, negative, positive, negative, positive, positive, negative, negative. Here in this part, في الجزء ده بس, we have what? We have series connection. So E equal what? E equal 1.5 times 2 equal 3 volts. And in this part, في الجزء ده, as you see here, like that, E equal what? E equal E1. And E1 equal what? 1.5 volts. So if we add what? 1.5 to 3 volts, we have what? We have 4.5 volts. Two parallel and two series. So we answer number 1, number 2, number 3. May I have question number 4? Electromotive force equal 3 volts. خلي بالنا by two ways, بطريقتين. So I need 3 volts. If we have here 2, as you see like that, parallel equal how many? Equal how many? Yes, equal 1.5. And we have another, what here? We have another parallel. The electromotive force equal how many? Yes, equal 1.5. So 1.5 plus 1.5 equal how many? Equal 3 volts. Equal what? 3 volts. So, dear students, the first way to connect, here we have positive, negative, positive, negative, 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 and here we have positive, and here we have positive. So, we have in this part, what? 1.5, because they are parallel. And here we have 1.5 because they are a parallel. So total equal what? Equal 3 volts. By first way. May we have another way? How come? عندنا طريقة تانية على فكرة. To connect the 4 cells and obtain 3 volts. Obtain what? 3 volts. This way, نحطها كده في نفس البيج قدامنا. If we have, as you see, 3 parallel and 1 series. If we have a third one like that here. So we have how many? 3 parallel equal what? Yes, equal 1.5. And what? and 1 cs. 1 cs equal what? Equal 1.5. So total equal how many? Yes, the total equal 3 volts. The total number equal what? Equal 3 volts. So, as you see here, dear students, we have two ways, زي ما احنا شايفين قدامنا طريقتين. We obtain from these ways. How can we obtain by two ways? Electromotive force of the cells as 3 volts. As 3 volts. So, dear students, now we know at the end of this lesson, how can we mention the types of electric current. We have two types of electric current, alternating current and direct current. Alternating current can be transferred for long distances, can be changed into direct current, and has alternating, or which means ان هو متغير, has variable intensity and direction. So we prefer to use alternating current than direct current. Why? Because it can be changed into direct current, can be transferred for a long distance or transmitted for a long distances, and has variable intensity and direction. So we use alternating current in many uses: lighting of streets, houses, operation of machines. In this studio, الاستوديو اللي احنا فيه دلوقتي, all these machines or appliances or devices work by alternating current. بس this alternating current it change into what? It change into direct current, because this laptop work by direct current, not like this camera, not like this lamp and so on. يبقى عندنا, we should know the alternating current at your home change into direct current. And we have two types of the electric cells. We have connection series to obtain maximum electromotive force, and we connect the electric cells parallel to obtain minimum electromotive force. Okay, dear students, next time, inshallah, we have to finish Unit 2, as we will start next episode with Lesson 3, the nuclear energy and its uses and its harms of this nuclear energy. I hope you get more benefits from this lesson. Thank you for watching, and see you soon, and goodbye.